This is SpaceTime, Series 24, Episode 12. Coming up on SpaceTime, the Earth spinning faster than it used to. Hubble pinpoints the origin of a mysterious supernova blast. And Blue Origin undertakes another successful test flight on its way to achieving a reliable means of space tourism. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has determined that the Earth is now spinning faster than it used to. In fact, the planet's fastest 28 days, based on records going all the way back into the 1960s, all occurred in the year 2020. The increased rotational speed, which is several milliseconds quicker than average, comes after decades of satellite observations clearly showing the planet's rotation to be gradually slowing down. That slowdown in planetary rotation follows normal planetary physics. It's due to gravitational tidal interactions with the Moon, which is gradually moving away from the Earth at a rate of about 3 centimetres per year. In fact, since 1972, scientists have been forced to add leap seconds roughly every year and a half on average. The last being in 2016, when on New Year's Eve at 23 hours 59 minutes and 59 seconds, an extra leap second was added. Earth's average day, known as the mean solar day, is 86,400 seconds. That's the amount of time it takes for any given point on Earth to complete a full rotation from solar noon to solar noon, when the Sun is exactly at zenith. Of course, Earth's rotational speed varies all the time due to variations in atmospheric pressure, tectonic plate movements, mountain erosion, snowfall, winds, ocean currents, and movements in the planet's core. Official clocks get adjusted when the planet's rotation deviates by more than 0.4 seconds. However, the recent acceleration in Earth's spin has scientists talking about a negative leap second for the first time. Instead of adding a second, they may need to take one away. Right now, that increased rotational speed means a day in 2021 will average about 0.05 milliseconds shorter, which over a full year will add up to something like 19 milliseconds of lag time. Earth's previous record for the shortest astronomical day was set on July the 5th, 2005, which was 1.0516 milliseconds faster than the average 86,400 seconds. And the shortest day last year was July the 19th, when the planet completed one spin some 1.4602 milliseconds faster than that usual 86,400 seconds. To find out more and work out what's going on, Andrew Dunkley is speaking with astronomer Professor Fred Watson.
Earth is spinning faster than it used to. Someone suggested the Treadmill Effect. I suspect otherwise.
Actually, the Treadmill Effect is as good a guess as any, because at the moment, nobody knows why. So, yeah.
Oh, well, that was a short segment.
Yeah, it's a theory that, is should go into the mix for what the reason is for this faster spinning Earth that we're seeing. And it sort of flies in the face of the normal wisdom about the spin. We've known ever since the invention of atomic clocks, and probably a little bit before that, actually. But we know that the Earth's rotation is not constant. It's a very poor timekeeper. And it's because its spin is affected by things like the sloshing around of the liquid iron core in the middle, the solid iron core in the middle and the liquid iron core above it, and the convections in the mantle. But it's also affected by other things like melting ice sheets and ocean currents and things of that sort. All of those things affect the rotation of the Earth. But, as you and I have spoken about before, Andrew, the normal way it changes is by slowing down. And that's because of the tidal friction effect between the Earth and the Moon. The Earth is gradually putting energy into the Moon, which makes it recede away from us. And that energy has to come from somewhere. And by and large, it comes from the slowdown of the Earth's rotation. But it's not just a constant drift downwards. It's got bumps in it. And we had a bump effectively last year. 2020 apparently had more short days than we've had for quite a while, which means that the spin is going up.
No, I knew that last year felt quicker. Everyone said, how How fast did 2020 go?
It went like a
That
rocket.
was it.
That's why, yes. Well, the shortest day was, by day now, we don't mean daylight or anything like that. It's the standard day is 86,400 seconds. That's how many seconds you've got in a day, which is 24 times 3,600, the number of seconds in an hour. So the shortest day was actually July the 19th last year, the depths of our winter down here in Australia, but high summer up in the Northern Hemisphere. So that 86,400 seconds was short by 1.4602 milliseconds. So it's not really something you'd notice, but it is a short day.
Blink and you would miss it.
You definitely miss it. Yes, blinks are usually longer than a millisecond, so you would. You should say that nobody's worried about this particularly. It's just a reflection of the fact that the Earth is variable in its spin. And exactly as I was saying, things like the movement of material within the Earth. But also, I think to some extent, we're seeing the sensitivity of the Earth to what actually happens on the surface. And that's because on the surface, there's effectively what's called a bigger moment of inertia, so that things that happen on the surface actually have a bigger effect. And that's why just the level of snowfall, for example, over a continent like Greenland or over an island like Greenland, and even things like the erosion of mountains by glaciers and that sort of thing, all of these can change the speed of the planet's spin. The other side of it, and maybe this is a little bit more concerning, is that atmospheric and climate scientists are looking at this as perhaps us seeing something like the effect of global warming, where you've got snow caps melting and the snows high up in the mountains actually disappearing. So it's really, it's an interesting yardstick, and it may mark the beginning of changes in the way the Earth rotates. Now, the people who are really most upset about it are the computer scientists, and they always are, because that's why computer scientists hate the fact that the Earth's spin is gradually slowing down, because in order to compensate for that, we introduce leap seconds periodically. I think there's something like 30 been introduced since 1975, was it? The first time a leap second was put in. But their computers need to be adjusted if you put a leap second in, and that's a big pain in the neck, because it's on systems on board spacecraft, it's all over the place where things have got to be changed. The idea of the Earth speeding up a bit could mean that you put in a negative leap second. That's to say, you take out a second at the end of a 6-month period. It's either the 30th of June or the 30th of December that these are put in. So you could take one out, and that, again, could lead computer scientists to tear their hair out and have all kinds of problems. So they're the ones who are most directly affected by this. But I thought it was a really interesting piece of research to point out that actually occasionally the Earth's spin speeds up.
Yes, it is. It's fascinating. I believe the first leap second was added in 1972. You weren't far off. And, when the Earth slowed down a little bit. And there's been, I think, 27 leap seconds all up, thereabouts. I did have a question. You mentioned at the beginning that the tidal effect of the moon is supposedly slowing the rotation of the Earth, but we also know the moon is creeping away from the Earth and will over time go. Will that change the spin of the Earth as it moves away, or is that too slow an effect?
No, the two are intimately linked, Andrew. And the moon will never disappear. It will settle down about 500,000 kilometres away. This is in something like 50 billion years. It's nothing to worry about. So it's the gravitational interaction between the two that causes both of those phenomena, the slowdown of the Earth, which is because it's giving energy to the moon. It's a fairly complicated process, but it's all about the way the tidal bulge on the Earth actually acts gravitationally on the moon itself to give it an acceleration. And that acceleration moves it further out in its orbit. So yes, two intimately linked processes, both of which are very interesting, I think.
You mentioned the bulge. I actually looked it up once, and I think we have talked about it once or twice. The bulge is responsible for quite a significant difference between the width and the height of the planet. It's quite a large variation.
That's the equatorial bulge. Yes, the bulge caused by the spin.
Equatorial bulge. Sorry,
there's too many bulges here. Yes, the Earth has an equatorial bulge. It's fatter around the middle, as are pretty well all the planets. Saturn is the most. Saturn is 10% wider across its equator than it is at the poles. But wait for this. One of the amazing facts is how perfectly spherical the sun is. So the sun is 1.3 thereabouts million kilometers in diameter. And yet the difference between its equatorial diameter and its polar diameter is less than 10 kilometers. It's staggering. So it's absolutely a perfect sphere, which is really quite remarkable.
If the Earth was spinning a bit faster in 2020, does that mean the bulge, the equatorial bulge, got a bit bigger?
Yeah, it probably, but the amount, yes, it would be about a millimetre or something like that, probably. Exactly.
Well, that's too much. That's about 10 millimetres.
Yeah, that's too much. That's an overestimate. So
That's Dr. Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. Still to come, Hubble pinpoints the location of a mysterious supernova blast, and Blue Origin undertakes another successful test flight in preparation for the beginning of space tourism operations. All that and more still to come on Space Time. Astronomers using the Hubble Space Telescope have determined the epicenter of a supernova explosion which would have lit up the skies of Earth some 1700 years ago. Scientists were able to determine the location based on the current position and movement of a supernova remnant, the expanding gaseous corpse left behind by the explosive death of the doomed star. The supernova remnant, named 1E0102.2-7219, is located some 200,000 light-years away in the Large Magellanic Cloud, a neighbouring satellite dwarf galaxy orbiting the Milky Way. Because the gaseous knots in the supernova remnant are all moving at different speeds and in different directions from the supernova explosion epicenter, astronomers were able to obtain Doppler shift measurements based on spectroscopic observations of the debris using Hubble. The observations show ribbons of gas accelerating away from the explosion site at an average speed of 3.2 million kilometers per hour. Now, to put that in perspective, it's fast enough to travel to the moon and back in just 15 minutes. The study's authors analysed the data to calculate a more accurate estimate of the age and centre of the supernova blast. Now, according to the new estimates, light from this blast arrived at Earth 1700 years ago. That's roughly the time of the decline of the Roman Empire. The supernova would only have been visible to inhabitants of Earth's southern hemisphere, and so far no one's found any written records of this titanic event. Previous studies had proposed explosion dates somewhere between 1,000 and 2,000 years ago. But as well as being more precise, the new analysis is also far more robust. The calculations are based on studies of tadpole-shaped oxygen-rich clumps of ejecta flung out by the supernova blast. Ionized oxygen is an excellent tracer because it glows brightest in visible light. By using Hubble's powerful resolution to identify the 22 fastest-moving ejecta clumps or knots, the authors determined that these targets were the least likely to have been slowed down by passage through interstellar material. They then traced the knot's motion backwards until the ejecta coalesced at a single point in space. That would have been the epicenter of the explosion. And once that was known, they could then calculate how long it took these speedy knots to travel from the explosion centre out to their current locations. Astronomers also used Hubble to measure the speed of a suspected neutron star created out of the progenitor star's core in the explosion, and which was flung out during the blast. And based on their estimates, this neutron star must have been moving at more than 3 million kilometers per hour in order to have travelled from the centre of the explosion to its current position. The suspected neutron star was identified in observations using the European Southern Observatory's Very Large Telescope in Chile in combination with data from NASA's Chandra X-ray Observatory. This is Space Time. Still to come, Blue Origin undertakes another successful test flight, and SpaceX conducts its first launch for the year. All that and more still to come on Space Time. This episode of Space Time is brought to you by LastPass, simplifying your online life. Now, if you're anything like me, one of the biggest frustrations and time-consuming parts of going online anywhere is trying to remember and then use all those login details and passwords that you've built up over the years. And again, like me, you probably already have hundreds of them. Of course, on the other hand, you could just be like a lot of other people out there and simply use one password for everything, and that's not a particularly secure idea. But I guess it could be worse. You could be one of those people that use 1, 2, 3, 4, 5 or A, B, C, D, E, or worst of all, you could use password as your password. And with the internet getting more and more dangerous, now really is the time to do something about that. And the good news is there's a great solution out there. It's called LastPass Password Manager. And with it, suddenly all those security hassles are gone. And believe me, the relief really is unbelievable. Not to mention the time it saves you. And it's so convenient having everything stored in the one manageable dashboard. If you sign up for LastPass, you'll be joining some 25.6 million fellow users around the world and more than 70,000 businesses. Now, you've got to admit, that's a lot of trust with one of the most important aspects of online life. And the good news is all this peace of mind is really affordable. If you want, you can simply sign up for the free service and leave it at that. Or for even more features, get the premium package for just $4.50 a month. There are family and enterprise plans available as well. Plus, LastPass works across all devices and even suggests super secure passwords for you to use. So, why not put your passwords into autopilot and reduce the stress? You can check out LastPass at spacetimewithstuartgary.com/LastPass. That way, you'll be helping to support our show. So, sign up and use it for free at spacetimewithstuartgary.com/LastPass and simplify your life. And like always, you'll find the link details in the show notes and on our website. That's spacetimewithstuartgary.com/LastPass. And now, it's back to the show.
This is SpaceTime with Stuart Gary.
Well, while Virgin Galactic's still licking its wounds following the abort of its latest Spaceship 2 test flight, space tourism competitor Blue Origin has carried out another successful launch to space from its West Texas facility. New Shepard mission NS-14 reached an apogee, that's a maximum altitude, of 350,827 feet. That's 107 kilometres above the Earth's surface, well above the 100 kilometre or 328,000 foot Kármán line, which marks the official start of space, the point in the atmosphere where aerodynamic surfaces can no longer control the flight of an aircraft, and reaction control systems are needed instead. The unmanned suborbital launch marked the first flight for the New Shepard 4 capsule, which is fitted out with additional amenities for space tourists, including improved acoustics to dampen engine noise, better interior temperature regulation, new crew display panels, and speakers with a microphone and push-to-talk button at each seat.
Welcome back for New Shepard's 14th mission to space. Gantry retracting there. We are getting ready for a launch, Patrick. This is when it gets really exciting. All right. We have thrown the show over to the rocket. She is in autonomous mode right now. We're waiting to see the final hydraulic system checks and engine gimbal check. There you go. The aft fins, making sure they've got full clearance there. There are 4 fins on the base of that rocket. We want to check these aerodynamic surfaces and systems before flight. This is just exactly what a pilot does on an aircraft. Waiting here for the engine gimbal check. The nozzle there peeking out. The engine is also obviously to propel the rocket, but is critical in guiding the rocket on its ascent, but as well as on its descent as it comes into land on the northern landing pad just 2 miles north of where the rocket is taken off from. Here we go, New Shepard. Have a great flight, Mannequin Skywalker. Enjoy that shiny new capsule, and we'll see you back home soon at Launch Site 1.
Guidance internal. T-minus 10, 9, 8, 7, 6, 5, 4. Command engine start. 2, 1. Ignition.
Mission Control has confirmed New Shepard has cleared the tower on her way to space from Launch Site 1 in the West Texas desert with Mannequin Skywalker on board. Right about now, the fins on the aft portion of the vehicle are going to help the vehicle do its roll maneuver. The booster is going to be rolling at about 2 to 3 degrees per second, which equates to a full rotation of the vehicle every 2 to 3 minutes. This, of course, is to give the astronauts a 360-degree view during the flight. All right, coming up here on max Q, maximum dynamic pressure on the rocket is the toughest portion of the flight for the rocket. And we've confirmed max Q. Excellent. Now, Mannequin Skywalker in there, starting to feel those G's, around 3.5 G's on the way up to space. It's very similar to a roller coaster, but in that horizontal position of the seats, definitely is a much more comfortable ride. All right, now approaching main engine cutoff, or MECO. So we're going to shut off the BE-3 engine. MECO is confirmed. Separation of the two craft is confirmed. New Shepard's 14th mission to space. The maiden launch for this rocket. So far, everything appears to be nominal. The two craft have separated. Right about now is when, if you were an astronaut in there, that's when you'd be able to float around, gaze out of those huge, gorgeous windows, maybe even do a somersault or two. I know I would certainly do that. There you go. It's hit 0, and now they are heading back home. We should have an unofficial apogee altitude coming up here shortly, but we have gone well over 100 kilometers. The Kármán line, the official line of space, and there it is, 350,827 feet above, I believe, mean sea level. So that is excellent. A great flight, well over the Kármán line. Mannequin Skywalker is an astronaut once again. Now, the capsule should be continuing to do its slow spin. Everybody gets a window seat in the capsule of New Shepard, but now we're making sure everybody gets the perfect view. All right, the two craft are heading back home now. The booster is going to beat the capsule back home. Obviously, it's more aerodynamically shaped, and so it's going to come down first. Right about now, in the next 10 to 15 seconds or so, this is when we expect the rocket to hit atmospheric pierce point. That means that's when it's coming back in, and it's back home from space, and it has enough air pressure upon which it can use its aerodynamic surfaces to push, and that will help guide the rocket back to its landing pad, again, 2 miles north of where it's taken off from. We have confirmation that the wedge fins have been deployed. Those fins are at the forward section, the top section of the rocket. They're housed in the ring fin. They also help provide stability for the rocket as it comes into land. And this booster is screaming home right about now. Its maximum return velocity is just under Mach 4. So we're looking now for the drag brakes to deploy. As soon as those deploy, you'll see the speed come down very rapidly. And then in quick succession, we're going to get the BE-3 engine to restart. The landing gear will deploy, and then the booster will come in for a nice soft touchdown. There are the drag brakes. Engine restart. Landing gear deployed. And touchdown. Welcome back, New Shepard. The show is not over.
That's right.
We still are waiting here for the crew capsule to come back. As noted, first the drogue chutes will deploy. Those are like the guide parachutes. The mains will then deploy. You'll also see the mains then inflate to full inflation. And once they're fully inflated, that's when the crew capsule starts to slow down, comes in, a nice 15, 16 miles an hour, a nice cruise back home. We'll wait for it to come back in to our valley in West Texas, and it will land. And just in the last milliseconds, the retrothrust system fires, and it creates a nice air pillow, if you will. So Mannequin Skywalker, by the time he touches down, it's just at about 1 mile an hour. It's a nice, soft touchdown. The crew capsule has its mains deployed, fully inflated. What an incredible day for the team. You know, Mannequin Skywalker, I mean, if he had adrenaline, his heart would be thumping pretty hard. What a day. All the way up over the Kármán line and back, coming in for a nice soft cruise back into our West Texas Valley there. Just about 400 feet above ground level. We're waiting for the retrothrust systems to fire, and then a nice soft landing. And touchdown. What a day. Congratulations to all of Team Blue. Really well deserved. This is our 14th mission, a safe landing for the booster, Safe landing for the crew capsule.
While all the new Shepard flights have so far been unmanned, they are at least reaching space, and doing it really reliably. And that's something Virgin Galactic are yet to achieve with their VSS Unity spaceplane. Despite their claims of having reached space during test flights in December 2018 and February 2019, the truth is Virgin Galactic's Unity spacecraft has only reached the US definition of the start of space. That's an altitude of just 80 kilometres at 260,000 feet, well below that official internationally recognised boundary of 100 kilometres or 328,000 feet. And Blue Origin's rocket ride will be a very different space tourist experience compared to that offered by Virgin Galactic. Virgin's spaceplane takes off horizontally from a conventional runway, mounted under the centre wing spar section of a specially built aircraft, before being drop-launched at an altitude of around 50,000 feet, igniting its rocket engine and then accelerating to the edge of space. Blue Origin's new Shepard launches vertically, like most orbital rockets, with passengers riding up on a launch tower and walking out on a gantry to the capsule. And there's a proper launch countdown once they're strapped into their seats, just like on a manned orbital mission. This is SpaceTime. Still to come, SpaceX conducts its first launch for the year, and later in the science report, British Prime Minister Boris Johnson claims the so-called mutant UK strain of COVID-19 is 30% more deadly. All that and more still to come on SpaceTime. SpaceX has commenced its 2021 launch year with a spectacular nighttime flight of a new Turkish telecommunications satellite. The Turksat 5A mission blasted off aboard a Falcon 9 rocket from Space Launch Complex 40 at the Cape Canaveral Space Force Station in Florida.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. And liftoff.
The vehicle is pitching downrange.
And here we go. We're now 30 seconds into flight on the Falcon 9. All engines are running at full power. We are preparing to enter through our first major milestone after liftoff, max Q. It's going to occur at T plus 1 minute 12 seconds. We're going to throttle those engines down. We've confirmed nominal status from the avionics team. Next, max Q. That's when the vehicle experiences the greatest amount of dynamic pressure. We throttle those engines down, and afterwards we throttle them back up to keep dynamic pressures below a certain level.
Falcon 9 is supersonic. Max Q.
We've successfully crossed the max Q threshold. Everything is looking good with the first stage's trajectory. Next, we're going to start our MVAC chill. This is going to help us prepare for the next 3 major events. They occur one after another. The first one, those 9 Merlin 1D engines are going to cut off. That's known as MECO, or main engine cutoff. Right after that, the first and second stage will separate, and then the Merlin vacuum engine on the second stage will turn on. That's known as SES-1.
Main engine cutoff.
Stage separation confirmed.
All right, all good news here. We had successful main engine cutoff, stage separation, and second engine start 1. Our next milestone is fairing deployment. Those 2 fairing halves on the top of the second stage are no longer needed, and we'll jettison them to help expose the Turksat 5A satellite to space and attempt to recover those later on.
Second stage is on a nominal trajectory. Fairing separation confirmed.
We just jettisoned our 2 fairing halves.
The 4,500-kilogram satellite, built by Airbus Defence and Space, is equipped with Ku and Ka band transponders, providing television and internet broadcast services over a footprint including Turkey, the Middle East, Europe and Africa. The launch marked the 4th flight for the same Falcon 9 core stage booster, which then successfully landed on the drone ship, just read the instructions, which had been pre-positioned downrange in the North Atlantic Ocean. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. British Prime Minister Boris Johnson says the so-called mutant UK strain of COVID-19 is 30% more deadly. Previously, the British government claimed the strain, which spread more easily than the original version of SARS-CoV-2, that's the virus which causes COVID-19, wasn't any more lethal. However, new findings based on 4 studies concluded there was a 1.3-fold increased risk of death, meaning that for every 1,000 people aged 60 or older who contracted the new strain of the virus, between 13 and 14 would die, compared to 10 from the original strain. The new strain, which emerged in southern England in October, is between 30% and 70% more transmissible than the original virus. More than 2 million people have now died, and over 100 million have been infected by the COVID-19 pandemic, which spread globally out of its Wuhan, China epicenter after the Chinese government ordered local doctors to cover up the seriousness of the deadly disease. A new study warns that a quarter of all bee species haven't been seen over the past 30 years. The 25% decline reported in the journal One Earth is based on the Global Biodiversity Information Facility database, which studies records of more than 20,000 different species of wild bee. Scientists found the bee declines weren't evenly distributed, with records of species in rarer families of bees declining more than species in some of the more common families. Any change in bee populations is important, because bees are one of the key pollinators of plants, many of which are used to feed people. A new study has found that aspirin may help breast and bladder cancer patients live longer. A report in the Journal of the American Medical Association found a study of nearly 140,000 people looking at the effects of aspirin use on developing and surviving bladder, breast, esophageal, gastric, pancreatic and uterine cancers found that while aspirin wasn't associated with actually preventing cancers, it was associated with increased bladder and breast cancer survival. Put simply, people with bladder and breast cancers who used aspirin lived longer than those with the disease who didn't. Paleontologists have reconstructed the only fossilized dinosaur cloaca in existence, research which may help them understand how prehistoric animals mated. The cloaca is a sort of all-purpose opening in the body of many animals, including fish, reptiles and birds. It's used for mating, egg-laying, urinating and defecating. The study's authors discovered a surprisingly intact cloaca in 2016 in the fossilized remains of a meter-long Psittacosaurus hornbilled dinosaur. A report in the journal Current Biology claims the authors were able to reconstruct the cloaca and compare it to modern-day animals. Most birds, which evolved from theropod dinosaurs, reproduce using cloacal kissing, in which the cloacas touch. However, it seems that Psittacosaurus had 2 flaps of skin covering most of the cloacal vent, similar to that found in crocodiles. And male crocodiles have a penis that emerges from the cloacal opening during mating. And the authors suggest that Psittacosaurus probably did the same. Well, if you're one of the tens of thousands of people trying to get in touch with Telstra customer service recently, you quickly discovered that you couldn't. Instead of a helpful, friendly assistant willing to go that extra mile to resolve your problem, customers ended up talking to a generic automated answering service, which forced them to listen to what seemed like an endless list of non-applicable options before finally telling them that they need to use an SMS instead. Telstra then let customers waste their time for several more minutes carefully typing out their message, their pleas for help, but as soon as they clicked the send button, instead of being magically transported on gossamer wings to a saviour who helped them resolve their electronic issue, you simply ended up with a message saying failed to deliver. And no matter how many times you retype and resend the same message, the result inevitably was the same unsatisfying abyss of despair. It seems there must have been so many customer complaints, Telstra's service couldn't handle it all. Now, what all this really means is that, thanks to the COVID-19 pandemic, the nation's largest telecommunications company came up with a neat excuse to avoid its responsibilities in terms of customer service. In fact, last year saw Australia's Telecommunications Ombudsman's Office receive a record number of complaints about Telstra. In fact, over the past year, the Ombudsman's Office has seen a 1,500% increase in complaints about the telecommunications industry, with torturous Telstra getting by far the lion's share, making up more than half of all complaints. And the battle against evil electronics, terrible transistors and psycho circuits isn't limited to Telstra. One of Australia's largest supermarket chains was forced to close its stores recently after key parts of its computer system crashed, leaving staff unable to process payments at the checkout. Customers were forced to abandon their treasure trove, trolleys full of carefully selected goodies, family staples, and that's something special, and exit the stores, leaving staff to return groceries and other items back to their lonely shelves and empty fridges. Alex Zaharov-Reutt from ITWire.com says it's something we've got to get used to. No one likes them, but computer outages are just a sign of the times.
When I was growing up, we had water and power outages, but these days the internet can go down, your cell phone service can go down, and we just had a major supermarket chain that was down for several hours. Something was wrong with their payment system, and it was costing them $60,000 a minute. And I went to the competing supermarket, and they were packed because the other one was closed. And you can imagine if something similar happened in the US, it would be costing millions of dollars per minute. But this reminded me that we do have these subsea cables that connect continents. And I was invited to the tour of a ship called the Responder Submarine Cable Laying Ship that was connecting New Zealand, Australia, some islands in the Pacific, and the west coast of the US. And going on this ship was incredible. They had the huge ship, was all very industrial inside, big, giant cable directing things on the back of the boat. I don't really know how to explain it. We went through and looked at the deck, at the bridge.
There were tensioners and there were huge barrels, spools
cable.
with
That's
cable
right.
on them, yeah. And these things are fed through a spaghetti-like maze of pulleys to get the tension right before they're lowered into the sea.
And they also had to splice cables together. They had to repair cables. They had to put repeaters on there. So it was quite an incredible tour, and I managed to capture it all on film, and it was one of my most popular videos, and I created a bit.ly link. So very quickly, if you want to see that, bit.ly, bit.ly/cable ship. bit.ly/cable ship will take you straight to the YouTube video. It goes for just under an hour, and it's a fascinating look into that particular world.
That's Alex Zaharov-Reutt from ITWire.com. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from SpaceTimeWithStuartGarry.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGarry.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimeWithStuartGarry.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGarry on Twitter, @SpaceTimeWithStuartGarry on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.